Yes, hello, good morning, grade 10s. My name is Patrick Kamala. I am a tutor and educator for mathematics and physical sciences, grade 10 at Rositake College in town Pulukwane. If you want to join our extra classes, you can inbox me or call or WhatsApp on 0785 222 041. Otherwise, if you are at Nuldaland, you are covered. Now, those learners who are at our teaching center, please watch the video as well, and I'm sure you'll understand what you're going to discuss here, because most of the teachers have the same questions because they are current, Okay, now those learners at Nuldaland, as we go through this, please understand so that you can prepare for your test on Tuesday, that is 28 September 2021. Okay, let us proceed. The first question. It was saying that an object moving at a speed v has kinetic energy E. The kinetic energy now changes to a quarter E. The speed of the object is now, so not something that they are saying that the object is moving with the speed v. Okay, this is speed v here. And then what happens all of a sudden? It has kinetic energy E right together. Now, the kinetic energy now changes to a quarter E. Changes to a quarter what? A quarter E. So they are saying that the speed of the object now is, in other words, this is V final. Okay. So this is V final, like this is our V initial here. So now, how do you find the kinetic energy anyway? What does the formula say? Anybody who has an idea? Now, how do you find the kinetic energy? The formula says that E equals to what? It says that E equals to half mv squared, né? So I can say that a half, okay, a half times mass, né? Times mass, okay, times V initial, that is VI here, squared, is equal to E. Equals to what? Equals to E. Hope we are together. Now, we know that in the case you forget this one, just check on the formula sheet. It's already given to you. So here, if I make, because we're talking about speed here, I'm going to make my V the subject, the speed the subject here. So this 2 is going to be multiplied here, then the m divided. So I'm going to get my VI squared, okay, equals to what? Equals to 2 times E, that is 2E, né? That's to what? 2E. What does E represent? That is kinetic energy, né? All together. And then divided by M. Divided by what? By M. Divided by M. So if I want to remove my square here, what do? I square root, né? I do what? Square root both sides. This is V initial, the initial speed. Now if I find the square root here, I'm gonna have it that V initial, okay, V initial equals to what? Equals to square root of what? Of this thing altogether. Okay. So square root of 2E over what? Over M. 2E over M. Okay. Now the question says that now we know what happens. They're saying that the kinetic energy changes to a quarter E, changes to a quarter E, which means that to get my final speed, which I'm going to call V final, I'm going to substitute. Where there is E, I'm going to put a quarter, né? So it's going to be V final equal to square root, okay, of what? Of 2, of this 2 multiplied by E, but this time my E is a quarter. It's a quarter of E, because they said it changes to what? To a quarter in, so it's going to be a quarter here, a quarter, a quarter here, okay, that's 1/4, okay, then times E was the first kinetic energy, okay, so then everything divided by what? Divided by M, divided by M, okay. Don't forget that this root sign also includes the M, I know some of you might get lost here. Now this root sign also includes the M, so I have to make it longer. Okay, so comes like this. Now watch this, I'm gonna get my answer shortly, guys. Now talk to me. This is a quarter, If this quarter is removed, what's left under the square root sign is what? It is 2e/m, which is the same as what you see here. Let me repeat this. This is 1/4. If 1/4 is taken out of the root sign, what is left inside is what? It's going to be 2 times e divided by m, which is the same as 2e/m here. Okay, now talk to me. When a quarter goes outside the square root, it means that we must find its square root, We must find its what? Its square root. So what do we do then? Talk to me. So if I get square root of a quarter, it's going to be what? It's going to be 1/2. Okay, so I'm going to write it as 1/2. So this means it's equals to square root of a quarter is 1/2. I think we are together. 1/2. Then left with the square root again now. Okay. What is the square roots again? We said it's what? It is 2 multiplied by e divided by what? By the mass. Okay. But if you check carefully here, you see that this one, let me use now a red color. This thing here, this term here, this one here, this one is the same as this one here. Okay, the same as this one here. And if they are the same, and yet this one is equal to V initial, it means that my V final, the speed now is going to be a half times the V initial. It's going to be what? It's going to be a half times what? Times V initial, because now we have seen that the V initial is the same as square root of 2e/m, so it's going to be times V initial, which in the question we can take to be what? To be V. So that's how we get our answer to be A. So speed now is going to be a half of V. So the answer is what? The answer is A. Hope we are together. If we are not, please pause the video and watch it again. Okay, or you can inbox me anyway. Let us proceed here. Next question says that the frequency of a wave is defined as the, what is it here, guys? The number of complete waves per second. That's our answer. The number of complete waves per second. In case you forget, revise your notes. But frequency of a wave is defined as the number of complete waves passing a fixed point in 1 second. Okay, so the answer is C. Okay. Next question, please. They ask the same question again, so they're giving you Mahara marks. So the frequency of a wave is defined as the number of complete waves per second. Still it is C. Okay, it is still what? C. Let us proceed next on the queue. We are saying that two wave crests overlap. The increase in amplitude is due to, now the crests are in the same direction, so when they overlap, they interfere, and the resultant pulse, the resultant wave is going to have a higher amplitude. So because of that, it means that what we are going to form as our resultant wave is going to be having a higher amplitude than the initial ones. Like here, if I, for example, this one here, if this one is maybe 1 meter, then plus another one here, which is, let me say, 2 meters. If this is 2 meters here, now when these two interfere, they form what we call as a bigger one. This one here. What is 1 plus 2? It is 3, so it's going to be 3 here. So as you can see, we have constructed a wave with a higher amplitude than any of the first two. So for that matter, the answer is called constructive interference. So the answer is what? The answer is D. Hope guys we are together. If so, let us proceed. They say here that the reaction between hydrogen chloride and sodium hydroxide is an example of. Now, hydrogen chloride is an acid. It is what? An acid. So, this is an acid here, HCl. Okay. And then this is a base, sodium hydroxide is a base. So reactions of acids and the bases are called acid-base reactions. So the answer is what? The answer is B. The answer is B. Okay. Let us proceed, guys. Hope we are together. Next, let's say consider the diagram of two pulses shown below. This one is moving to this other direction, as you can see. What about one here? Moving to the left, here to the right. It seems they both interfere at point X, they both meet at point X, okay? That's what they want us to do. They say that when the two pulses in the diagram meet at point X, the type of interference and resultant amplitude of the disturbance will be. Now, you know, because these amplitudes are facing opposite directions, okay? This one which is facing up, you can take it to be positive. Then facing down, you can take it to be negative. So in other words, you can say this is positive 30 centimeters, okay? Because they are interfering, we add according to the principle of superposition. Then plus now the negative what? Negative 20. Since it's facing down, this negative 20 here. Negative 20 here. So when you add negative 20 plus positive 3, what do you get? You get what? You get positive 10. Get positive what? Positive 10. So this positive 10, according to the principle of superposition, is the resultant amplitude after interference. Okay. So because now the 30 has been destroyed to give us something smaller, it means it's called what? Destructive interference, but with amplitude 10. So the answer becomes what? The answer becomes A. Let me explain again. I'm saying because the initial amplitudes have been made smaller, we say it qualifies to be called what? Destructive interference. Okay, that's our answer there. Let us proceed then. 1.7. They say an object is released from the top of a frictionless inclined plane AB as shown below. Okay. They say which one of the following statements regarding the total mechanical energy of the object is correct. Now they said something here. They said something that the slope, the plane is frictionless. So we know that if the slope is frictionless, if the slope is frictionless, it means that mechanical energy is conserved. That means mechanical energy at point A is the same as mechanical energy at point B, because along the way we didn't lose any energy. We didn't lose what? Any energy. So even here it will also be equal, because we didn't lose what? Any energy. Somebody can say, why is it like that? Because here the slope is frictionless. And I hope you remember what we said. We said that the law of conservation of mechanical energy says that the total mechanical energy in absence of dissipative forces like a friction force or a resistance remains constant. So meaning that the mechanical energy at point A is equal to the mechanical energy at point B. So what's mechanical energy anyway? It's the sum of EP and EK. So our answer becomes what? The answer becomes C, because here they said that mechanical energy at A, that is EP plus EK, will be the same as mechanical energy at B, that is EP plus EK at B. So the answer is what? The answer is C. Hope we are together. Let us proceed, guys. Which one of the following statements is incorrect about the properties of a physical change? They're saying, don't forget your English, they're saying incorrect, which means the rest are correct, okay? So let us find out which ones are correct. Then, of course, one which is not correct will be the answer. Let's check it out here. We're talking about physical change, don't forget. So when a physical change occurs, the compounds may rearrange themselves, but the bonds in between the atoms will not break. That is correct. And then physical change in matter is reversible. That's also correct. We know that, guys. Then energy is absorbed when matter changes from solid to liquid. That's also very, very correct. Okay. Now check here. Molecules are not conserved during physical change. That is incorrect. Because we know that if you have taken an example of the phase change, putting water in your glass and then put it in the freezer, water is going to freeze to give us ice out together. However, if you take out that ice and then you cool it down and then you put it somewhere where it is warm, it's going to give us exactly the same number, the same volume of the water which we had before. So it means molecules are conserved. So the answer here becomes what? The answer becomes D. The answer becomes D. Hope we are together, guys. Let us proceed then. They say that two molecules of hydrogen gas at STP occupy a volume of. Now all the gases at STP have got the same molar volume. Okay. Let me say this again. All the gases at STP. STP means standard temperature and pressure. They have the same molar volume, which is 22,4. In other words, one molecule of nitrogen at STP has 22,4 decimeters cubed, or 22,4 liters. Okay. Now likewise, one molecule of hydrogen gas at STP has 22,4. Okay. Now the question talks about two molecules. So if they're going to be two molecules now, it means I'm going to multiply. I'm going to multiply what? The 22,4 times what? Times 2. Times 2. So what do you get? Talk to me, guys. Talk to me. It's going to be 44,8. So the answer becomes what? Answer becomes B. Let me explain again. At STP, all the gases, whether hydrogen or oxygen or nitrogen, name it, they have the same volume, which is 22,4 liters. Okay, so that is for one molecule, or 1 mole of a gas. However, now if there are two molecules, it's going to be twice that at STP, which is 2 times 22,4, giving us 44,8 liters. Okay, hope we are together, guys. Let's proceed here. Let's consider the unbalanced chemical equation below. That is P4 solid plus H2 gas to give us pH3. Which one of these sets of coefficients will balance the chemical equation? So see, now what do? We have got 4 here. Let's balance it. So we're going to put another 4 here. You see, we're going to put what? Another 4 here. But the moment we put a 4 here, what happens, guys? Talk to me. The moment you put a 4 here, the 4 affects both the P and the H. So what is 4 times 3? It is 12. Look at my reactants. I've got only have 2 here. So how do I get 12 from here? by putting a 6 here. Why? Because 6 times 2 is 12. This one is just P4, so I only have one here. So what is my answer? 1, 6, and 4. So the answer becomes B. Answer becomes what? B. I hope we are together. Let us proceed to the next one here. Question 2 says that a 2 kilogram ball rolls from rest from point A on a frictionless track ABCD as shown below. The horizontal section BC of the track is 5 centimeters above the ground. The ball reaches point D 30 centimeters above the ground at a speed of 1.71 meters per second. Okay, please read the question again, class, and underline what is important. They said a 2 kilogram ball, that's my mass, rolls from rest. Did you hear that? Rolls from rest from point A on a frictionless track ABCD as shown below. The horizontal section BC of the track is 5 centimeters above the ground. This is my height for BC, above the ground. The ball reaches point D, which is 30 centimeters above the ground. So point D is what? It is 30 centimeters above the ground at a speed of 1.71 meters per second. So this is our final speed at point D. What are you supposed to do then? Write down one time for the following statement. Okay, which statement are they talking about here, guys? They're saying that the sum of gravitational potential energy and the kinetic energy, what is it called? It's called, talk to me now. It's called what? Mechanical energy. It's called mechanical energy. It's called mechanical energy. It's called mechanical what? Energy. So this is our answer here, which we say is the sum of the sum of what? Which you call the sum of gravitational potential and kinetic energy. So this is mechanical energy. That's our answer there. It is mechanical energy. Okay. Let us proceed. Calculate the mechanical energy of the ball at point D. So because the saying is the sum of EP and the EK, what am I gonna do? I'm gonna find the EP here and then the EK here, then I get the sum, and that will be my mechanical energy. Okay, let us do it. Let's do it together. Now talk to me. How do you find EP and EK? What does the formula say? So to get my EP, I'm saying the E Mech at D at this point here. The E Mech at this point D, that is E. E stands for mechanical energy. Is the sum of what? The sum of EP plus what? Sum of EP plus EK. But how do you find EP? It is mass times what? Gravity times height. What about the EK? It is a half mv squared. It is a half what? Half mv squared. Okay. So EP, we said it's mgh. So I'm gonna say it's gonna be here. Mgh, that is m times gravity. Okay. Times the height at D. Then plus a half mv squared plus a half. Okay. Times mass, okay, times V at D squared. Okay, so let's get the answer. So the mass we saw it is 2 kilograms. So I'm gonna say 2 here. I'm going to say 2 multiplied by 9,8. That's our gravity. 9,8 times the height. Now this height given here is in centimeters, and it must be in meters. So 30 divided by 100, you get what? You get what? 0,3. So 0,3 here. Okay. Then after getting my answer here, I'm going to add plus what? plus EK. But what is EK? It is a half mv squared. It's going to be now a half times still 2 because the mass is 2. The mass is 2. Then times the v at d, which is 1,71, but squared, 1,71 squared. So what's our answer here finally? Now our answer is going to be, if you get a calculator, it's going to be what? Let's take it out. Half mv squared. Half mv squared. Calculator, where are you? So here I'm going to open brackets. I'm going to say mgh, that is 2. That is what? That is 2. Okay. Let's do it together here. Okay, let me start afresh. Now I'm saying mgh, so that is open brackets. That is 2 times 9,8. Okay. Times the height, which was 0,3, 0,3. Close brackets. And plus open brackets. Now the EK is a half mv squared, Marot is a half, the same as 0,5. So 0,5 times 2 still, then times 1,71. Don't forget, must be squared. Must be what? Squared. Then close the brackets. So what's our answer, guys? 8,8. So our E Mech at point D is 8,8 joules. Okay, so if you go back to the whiteboard, we see that our E Mech at point D is what? It's 8,8 joules. Okay, 8,8 joules. 8,8 joules. That's our answer, guys. 8,8 joules. Okay, let us proceed. Let's say now what else must we find? They say calculate the initial height of the ball at point A. Calculate the initial height h of the ball at point A. So at point A, this height h is what I'm looking for, but don't forget that this track is frictionless. They said frictionless track ABCD. That means from A to B to C to D, there's no friction operating. So for that matter, we can say that E Mech is conserved. In other words, E Mech at D the same as E Mech at point A. So with those two at hand, I can make H the subject and then get my answers. We're going to see shortly. So don't forget what we are using here. I said that E mechanical at A equals to what? Equals to E mechanical at G. Here we go. Okay, so let's say that E mechanical at point A, the same as what? The same as E mechanical at point D. The same as E mechanical at point what? At point D. So let's now substitute. What is that? What does E mechanical mean? We say it's same as EP plus EK. So the EP and the EK at point A, the EP and the EK, everything where? At point A will be equal to ED. But what is our ED from our previous calculation? It is 8,8. Hope you remember that, guys. It is 8,8 joules. 8,8 joules here. So what is EP? It is mgh. It is mgh. Okay. What about my EK? At point A, it is a half mv squared. It is a half multiplied by the mass times velocity squared. Okay. Everything at point A, then I equate to what? Equate to 8,8. So this must be 8,8. Let me now substitute. They said that the mass is 2, it's going to be 2. It's going to be what? It's going to be 2. What about our gravity? It's 9.8, so I'm going to say 2. I'm going to say 2 here, multiplied by 9.8. Okay, 9.8. Then times the height h, which I'm looking for. Okay. Then plus a half mv squared, that's a half. The mass is still 2, guys, so times 2 here. Times 2. Now they said that this ball was released, which means that the velocity at a is 0. So that's going to be 0 squared here. Then everything equals to what? Equals to 8.8. 8.8. So 8.8. Now if I simplify this other side, I'm going to get here 19.6. 19.6. 19.6. Then h, okay, and then plus what? Plus 0. Because of the 0 squared, plus what? Plus 0 equals to 8.8. So how do I get my h here? Now talk to me, since you're not doing math light. So I'm going to divide 8.8 by 19.6. So what's my h? Divide that for me, guys. 8.8 by 19.6. So 8.8 divided by 19.6. What do you get? We get 0.45. So I have here 0.45 meters. 0.45 meters. That's my answer. 0.45 meters. Hope we are together. Thank you so much for watching, but we have to continue. Okay, so next they said that calculate the speed of the ball while it moves between points B and C. The speed of the ball as it moves along what? B and C. Now, because BC is also frictionless, it again means that mechanical energy at BC along BC will be the same as mechanical energy at what? At D, which is 8.8, all together. So I'm going to say mechanical energy along BC equals to mechanical energy at D. Why? Because the tracker was frictionless. Are we together? Let's check it out. Let's check it out together. I want initial speed, the speed of the ball while it moves between points B and C. So like we have said that the mechanical energy along BC, let's do it here. The mechanical energy along BC, let's say BC in brackets, okay, will be the same as the mechanical energy at point D, because the system suffers no friction. Okay, but what is ED here? We said it's already 8.8, so I would equate to what? I equate to 8.8 joules, okay. Then I can solve. But what does E make mean here? It means that the EP plus EK along BC equals to 8.8. So how do you find the EP? It's MGH along BC, MG what? M times G times height along BC, and then plus a half mv squared, that is a half, times the mass, then times v squared, but that is the v along BC, don't forget. Should give us what? Should give us 8.8. So now I'm going to substitute and see my answer. Now the mass is still 2, it is 2 here, times G, which is 9.8, and forget 9.8. What about our height along BC? it was 5 centimeters, but because it must be in meters, so divide by 100, which gives us 0, what? 0,05, 0,05, okay, and then plus a half times the mass, which is still 2, that is times 2, and then times V along BC squared, V along what? Along BC, V along BC, but must be what? Must be squared, so squared here, everything equals to what? Equals to 8,8, okay, so when I equate 8,8, so what do I do next? I compute this side here, that is 2 times 9,8 times 0,05, what do you get? Let's check it out. 2 times 9,8 times 0,05, it gives me 0,98. So this 0,98 here, 0,98, 0,98, okay, and then plus. Now if you take this 2, it's gonna cancel with this 2 here, right? So plus VB squared, that means speed along BC squared, okay? Speed along what? Along BC, but what? But squared, so equals to 8,8. So what do I do next here? I'm gonna say 8,8 minus 0,98 and I square that with my VBC. So my speed along BC is given by what? By that one there. So 8,8 minus 0,98, okay, so it's going to be square root of what? 7,82. 7,82. So what is it now? Talk to me, please. What do we get here? It gives us what? Square root of that answer, it gives us 2,8 meters per second, 2,8 meters per second, 2,80, yes, if you round up properly, it is 2,80, 2,80 meters per second, Hope we are together, guys. If we are not, don't worry. Just pause the video and replay it. Hope you really understand. Okay, let us proceed next. They're saying that the ball is now replaced with a 4-kilogram ball. The 2-kilogram ball is now what? Replaced with a 4-kilogram ball. They say, how will the speed of the 4-kilogram ball compare to the speed of the 2-kilogram ball at the point D? Choose from greater than, smaller than, or equals to. Give a reason for your answer. So what do you think here, guys? Now replacing the 2-kilogram ball with a 4-kilogram ball, what do you think? Is the speed going to be greater than after replacement, or is going to be smaller than or equals to? Actually, here the answer is equals to. The answer is what? Equals to. Give a reason for your answer. This is my reason here. Now this one is because the speed of the ball is because that the speed of the ball does not depend on the mass, but depends on the initial height of the ball. Speed of the ball depends on the initial height and not the mass. So that's why the speed will remain the same, because they haven't changed the height, they have only changed the what? Only changing the mass. So the speed is independent of mass, so our answer is what? remains the same or equals to, because the speed of the ball depends on the initial height and not the mass of the ball. I beg your pardon. Initial height and not the mass of the ball. So that's what it's gonna be equals to. Hope we are together. Okay. All right. Let us proceed. Next question here, guys. It says that the diagram below represents the transverse wave produced by source A. Let's check it out. By source A. Okay. So they say define the term amplitude of a wave. What is amplitude of the wave? It is the maximum displacement of the wave from the rest position. It is what? The maximum displacement of a wave from the what? From the rest position or from the equilibrium position. Of the wave from what? From rest position. So that's our amplitude. It is what? It's maximum displacement of the wave from what? From the rest position. Okay, then next they say here that that is amplitude. They say write down the amplitude in meters of this wave. So check our diagram again. If we check it again here, now where is it maximally displaced? It's from this rest position up to 50 marker here. So our amplitude is 50 centimeters. But what does the question want? They want it in what? They want it in meters. So what's our answer? Then it's going to be our amplitude A equals 50 centimeters divided by what? By 100. So we can convert it to meters. So if we do so, what do you get? We're going to get 0.5 meters. 0.5 what? Meters. So that's our answer for the amplitude. Okay. Then next they say that determine the period of this wave. Now period is the time taken for the complete wavelength to pass a point in seconds. Okay. So we're going to look at points in the phase, and then the time taken for those points to pass a point will be our period. Okay. Let's check it out now. Okay, so now our points in the phase which are here, we can have this one and this one, or we can have this one and this one all together. So now my period of this wave is going to be like, check here from this point, this is a complete wavelength. So the time taken for it to pass the point is what? It is 8 seconds. So my period is 8 what? 8 seconds for this wave. It is 8 what? 8 seconds for this wave. 80 seconds for this what? For this wave. Okay. Okay, next question says calculate the speed of the wave if the wavelength is 0.8 meters. Okay, calculate what? The speed of this wave if wavelength is what? 0.8 meters. Okay. Now they have given us the wavelength. They want the speed v. So how do you find the speed v? Talk to me now. Now the speed v is given by v equals to frequency times wavelength. Okay, that's our lambda here, times wavelength. Now in this particular case, the frequency is the same as the reciprocal of the periodic time. That means 1/t times 0.8. times what? 0.8. So which answer do we get here? So it's actually going to be here 1/8 times 0.8, ne? Because our t we said was 8 seconds. You remember that? So times what? Times 0.8. What's our answer then? What is our answer? It's going to be what? It's going to be 0.1 meters per second. Okay, meters per what? Per second. That's going to be our speed of the what? Of that wave. Now they say calculate the distance d on the diagram. So how long is the distance d? How many wavelengths is it? Let's check it out here. The distance d. Now our distance d gets all the way from this point to this point here. Let's check it out. So distance d, it gets from this point here to this point here. Ne? So let us find out in terms of wavelength. Ne? So from where it starts from, that's from here up to here is one wavelength. Ne? That's one lambda. That's one what? One lambda. Okay, one wavelength. And then also from here up to here is another wavelength. Ne? That's another lambda here. And then from here up to here it's a half of the wavelength. Ne? That's a half what? Half lambda. Half lambda. So because I know my lambda is wavelength, which is what? 0.8, like they said, I can now find distance d. Now that my distance d equals to 2.5 times the lambda, which is wavelength, 2 times what? Times yes, 0.8. 0.8. So which answer do we get now? Which answer do we get? So 2.5 times 0.8, we're getting 2 meters. So our distance d equals what? Equals to 2 meters. Distance d equals to 2 meters. 2 meters, the distance d. Hope we are still together, guys. Any questions, please inbox me. Don't feel bad, just inbox me. Just inbox me if you have any questions. Okay, let us proceed then, because we must finish this paper. Next we have they said that the diagram below represents a transverse wave produced by source B. So that's how it goes here. How does each of the following properties of the wave produced by source B compare to that of the wave produced by source A? Choose from greater than, smaller than, or equals to. Number 1 is amplitude. Now for the previous wave, I don't know if you remember, what was our amplitude? It was 0.5 or 50 centimeters. Okay. What about now for wave B? What's amplitude? It's more than 50, ne? So it means amplitude for this wave B is greater than the one for wave A. So I take a what? I take a greater than. That's my answer here. I take a what? Greater than. Then next they're saying frequency. Now the frequency is given by 1 over periodic time, ne? So the time to get from here, that's from one point in phase to another point in phase. So the time taken between these 2 points is our periodic time. Ne? What about our frequency? It's 1 over that time. That's going to be 1 over 4. So I'm going to compare these two. I'm going to compare for B, which is 1 over 4. That's my frequency. 1 over 4. Okay, 1 over 4. Compare it with 1 over 8. Compare it with what? 1 over 8. So if I compare with 1 over 8, talk to me now. This is for B. This is for B here. This is for wave A. So which of these two answers is bigger, is greater? Now in mathematics, the smaller the numerator, rather the smaller the denominator, the higher the fraction. So the answer is going to be greater than here. Again, I choose what? Greater than. I choose what? Greater than. Okay, that's our answer there. Let us proceed. Next. Calculate the frequency of the wave produced by source B. Now our frequency, like we said already, that f equals to 1 over t. 1 over t. And what is our t here? Our t is the 0,4, is the first second, sorry, it's going to be 1 over 4, which gives us what? Which gives us 0,25. 0,25. 0,25 hertz. So that's our frequency for this wave B. Thank you so much for watching. But we have to proceed so you can be ready for your paper on Tuesday. Okay, let's continue, guys. Next we are saying that two girls standing at opposite ends of a rope, each makes a pulse with of the same speed. Pulse A with amplitude 4 centimeters moves to the right, and pulse B with amplitude minus 6 centimeters moves to the left. The pulses meet at point C, so they all meet at this point here. What does the first question say? State the phenomenon observed when the two pulses meet at point C. Now these two pulses, when they meet at point C, they're going to interfere. And which phenomenon do we use here? It's called superposition. They want us to state it here. Okay, no stress. Let us do that. So the phenomenon is what? Is superposition. It is superposition. Now this superposition has got it. Is there we state it? How do we state it? It says that the resultant amplitude, when two or more pulses, when two or more pulses interfere, then is given by what? Is given, okay, pulses interfere, is given by the algebraic sum. Given by what? By the algebraic sum of the individual pulses. Algebraic sum of individual pulse amplitudes. Okay. We're saying that the principle is called superposition, stating that the resultant amplitude when two or more pulses interfere is given by the algebraic sum of the individual pulse amplitudes. Okay, hope we are together. Let us proceed. Next, they said that draw a label diagram to show the resultant pulse when the two pulses meet at point C. Okay, check it out nicely. Draw a label diagram to show the resultant pulse when two pulses meet at point C. Label the pulses clearly. Okay. Now, when they meet at point C here, both of them, let's see what's going to happen. This one is facing upwards by positive 4. This is facing downwards by negative 6. So when they both meet, I'm going to say negative 6 plus positive 4, which gives me negative 2. Because my answer is negative, it's going to be downwards. So I'm going to have something like this one here. So if this is the pulse length from here, so if this one is for A, okay, if this is for A, okay, and then if this is for B, let me now use black. If this is for B here, I mean initially, if this is for B initially, which was what? We said negative 6, So negative 6 with a positive 4. What do we get here? Let me get my resultant now in blue. So I'm going to have my resultant at point C like this now. Check. This will be the resultant what? Resultant amplitude. Okay. So don't forget this is pulse A. This was for pulse A. This was for pulse B. Okay. And this is my resultant. Now what is its amplitude? It's going to be negative 4. Because we said negative 2 rather, because we said that the negative 6 plus 4 gives us what? Negative 2 centimeter. That's our diagram. Okay, let us proceed, guys. Next is saying that name the type of interference that takes place when the pulses meet. Now, as you can see that the initial amplitudes of B was 6 and 4 for A. So because my resultant is lower in amplitude, it means that it is destructive, and hence the name what? Destructive interference. Hence the name what? Destructive interference. Destructive interference. Destructive interference. Okay. Alright, that's now the type of the interference. Okay, then next they're saying that determine the resultant amplitude out of the pulses at point C. So at point C here, my amplitude is going to be given by the sum, like I said there. It's going to be now A, that's my resultant, equals to the initial amplitude for A, which was 4 centimeters. It was positive, okay, 4 centimeters, and then plus what? Plus negative 6. Open bracket, negative 6. So if I add negative 6 centimeters and positive 4, what do I get? My answer is going to be negative 2. So it's negative 2 centimeters. That's my resultant amplitude. Okay, let us proceed. Next they said that what are they saying? How will the amplitude of pulse A be affected after passing point C? Write down only increases, decreases, or remain the same. Okay, now all these pulses, because we don't consider any energy lost, after interfering they continue with the same speed and also with the same amplitude and in the same direction as before the interference. So here the answer is what? Remains the same. The answer is remain the same. Okay, thank you so much for it. Let's proceed. Question 5 here. Consider the compounds Al2SO43. Write down the name of the compound above. So which compound is on here? Talk to me, guys. This is called what? It is called aluminium sulfate. It's called what? It's called aluminium sulfate. It's called what? Aluminium sulfate. So this is aluminium sulfate. Aluminium sulfate. Okay, that's its name. It's called aluminium sulfate. Next question. They say define the term molar mass. Okay. Now molar mass is defined as the mass contained in 1 mole of a substance. What is molar mass? It is the mass contained in what? In 1 mole of a substance. So molar mass is the mass contained in 1 mole of a substance. Should I say it again? Molar mass is the mass contained in 1 mole of a substance. Of what? Of a substance. Okay. What about molar volume? The volume contained in 1 mole of a substance. So here they want molar mass, ne? It is what? It is the mass contained in 1 mole of a substance. Okay, now let's calculate for the following, ne? The molar mass of aluminium sulfate. Okay, so now aluminium has got its atomic number, which is what? Which is 27. What about sulfur? 32. What about oxygen? 16. So we can now do the calculation to get our molar mass, which is capital M. So the molar mass, which is capital M, will be given by what? Let's get it here. Okay. So the molar mass, which is this one here, will be given by this formula here. Like we compute it on each of these and then get the answers. So the molar mass is capital M. Okay. Given by the mass for aluminium is 27. Next, I'm gonna have brackets, that is 27 multiplied by what? Multiplied by 2, because there are 2 of them, as you can see. And then plus, what about sulfur? Sulfur is 32, so open brackets, you can say 32 multiplied by what? Because of the 3 here, multiplied by 3. So multiplied by what? By 3. And then what do you have for oxygen? It's gonna be plus again, that is also mass for oxygen, guys. It is 16, multiplied by what? By 4, because of the 4 in brackets, and then by 3, because of the 3 also affecting the oxygen, so times 3 as well. So which answers do we get here? Actually, we're going to get 57 plus 54 for the aluminium, and then plus 96 for sulfur, then plus 192 for oxygen, which gives us 3 what? 342 as our total. Now don't forget that here it is important to have to know the units. You must know the what? You must know the units, otherwise you are not correct. So what are the units for molar mass? It is grams per mole. It is what? Grams per mole. So I'm going to say this is grams per mole. This is what? Grams per mole. Grams per mole. In other words, each mole of aluminium sulfate contains these grams. Okay. Alright, let us proceed. Now next they said that calculate the percentage composition of this stuff here. Now percentage composition, what we do, we use the total molar mass and divide each one by the total molar mass 10 times 100 to get a percentage composition like it's on here. Okay, now as you can see that for aluminium it is 54. So I'm gonna say that it's gonna be 54 divided by 342 times 100. What about sulfur? 96 divided by 342 times 100. About oxygen? 192 divided by 342 times 100 as well. So I'm getting my answers here. Okay. Okay. So what did I say here? I said for sulfur, it's gonna be what? Rather for aluminium, it's gonna be 54 divided by 342 then times 100 times what? Times 100. Which answer do I get here? You can compute that for me meanwhile. Then for oxygen, it's going to be 96 divided by 342 multiplied by 100 as well. And then lastly, for oxygen, this is for sulfur, then for oxygen it's going to be 192 divided by what? By 342 multiplied by what? By 100. Okay, so anybody with the answers out there, talk to me. Talk to me now. Okay, let's get these answers now. For this first one, which is aluminium, what's our answer? Let's check it out here. That is 5400 divided by 342. It gives us 15.79%. It gives us what? 15.79%, okay. What about for sulfur? Let's check it out for sulfur now. That's 192. It gives us 96. Yeah, for sulfur, it gives us 28.07. 28.07. 28.07%, okay, by composition. Then lastly, the percentage composition for oxygen, which is the biggest now, that's 190 now, gives us 56.14%. This is 56.14%. 56.14%. Okay, we hope we are together, guys. Let us proceed. Next, they're saying that the number of moles present in 85.5 grams. So, how do you find the moles N? Our moles N is given by the mass given divided by the molar mass. So the mass is what? Okay, this is the formula here. Mass over molar mass. This is now capital M. So it's gonna be 85.5. That is 85.5. Okay. Then divided by what? By 342. But by 342. So 342. Which answer do you get here? Talk to me. 85.5 divided by 342. What do we have? 0.25. 0.25. 0.25 moles. Okay. These are the moles contained in what? In 85.5 grams of aluminum sulfate. Okay. Next, it said the number of aluminum atoms present in 85.5 grams. Now, for me to get the number of atoms, I'm going to use the formula, which is like it's number, but I know that from my formula sheet, that the number of moles can also be given by N equals to the number of particles, that is N, capital N, divided by Avogadro's number, which is Na. Divided by what? By Avogadro's number, which is Na. So, for me to get my N, which you see here, this N here, it's going to give me the number of aluminum particles, aluminum sulfate particles present in 85.5 grams. So in other words, my N is my N will be the same as the number of moles multiplied by Na, Avogadro's constant. Okay, but if you check my N was what? It is 0.25, so it's going to be 0.25 multiplied by what? By Avogadro's constant, that is 0.25 times what? Times 6, what? 6,02, then times 10 power what? 10 power 23. Power 23. So which answer do I get here? So if I compute this on my calculator, I get something like this one here. That's 0.25 times what? 6.02 exponent 23. It gives me actually 1.50 exponent 23. Getting 1.505 1.505 times 10 power 23 times 10 power 20 what? Power 23. Okay. Now what about these particles which you see here? They are the particles of aluminium sulfate contained in this mass, the 85.5 grams. Let me say this again. This number which you see here is the number of particles of aluminium sulfate contained in 85.5 grams. But okay, let me say like this. Let me say that if aluminium sulfate is a packet, there are as many packets as 1.505 exponent 23 packets of aluminium sulfate. But the question wants us to know the number of aluminium atoms. Look at our formula again. Aluminium is twice, it's 2 times in that aluminium sulfate. So to get my aluminium atoms, I'm going to multiply all the number of packets together with by 2. So to get my answer, I'm going to say what? I'm going to use this one here. I'm going to use now to get the number of aluminium atoms, only aluminium now. Aluminium atoms is going to be given by this one here. This one here multiplied by 2. Why? Because each aluminium sulfate packet contains 2 aluminium atoms. So multiply by 2. What do you get then? We have 3.01 exponent 23. So it's going to be 3.01 exponent 23. Yes, 3.01 then times 10 power 23 times 10 power what? Power 23. Okay, hope we are together, guys. Now these are the aluminium atoms present in the mass of 85.5 grams of aluminium sulfate. Okay, next question. They said that particles of aluminium sulfate are bonded in a crystal lattice. Write down the following for this lattice, crystal lattice. So the name. Now if you look at our particles here, which we have aluminium ions and the sulfate ions. So the name which they form, because aluminium is positive, that's metals. What about sulfate is negative? It's going to be forming what we call as an ionic structure. It forms what? It forms ionic structure. So our name here is ionic structure. Ionic structure. Ionic structure. Formed by the positive ions from aluminium and the negative sulfate ions. So the name here is what? Ionic structure. Okay. Let us proceed here. Now they're saying the particles it consists. So the particles it consists here, we have the aluminium particles. You can say aluminium ions. Okay. And then what? And then the sulfate ions. So here the particles we have the aluminium 3 ions. Aluminium 3 ions. Okay, this aluminium 3 ions. And then the sulfate ions. Sulfate, that is SO4. Sulfate, that's with the 2 minus. Sulfate ions. Okay. So these are the ions which we have in here in this crystal lattice. Okay. Now they say two properties. Now such lattice says I've got its properties here. They are very brittle. So one of the properties is what? It's brittle. It's brittle. And then what else does it have? And because it's brittle, it means it is hard. It is hard. So another property is what? They are also hard. And not only that, but they don't conduct electricity. That's another property, ne? They don't conduct electricity, they don't conduct heat, and they have high melting points. All of the particles, you can write on any two of those, okay? Now they say that 500 grams of aluminum sulfate is dissolved in 2 deciliters cubed of water. Define the term concentration. So what's concentration? What is concentration? Now talk to me. Now concentration is the number of moles of a solute dissolved in 1 liter of a solvent, or you can say 1 decimeter cubed of the solvent. So concentration is the number of moles, of a solute dissolved in what? In 1 liter. In 1 liter of a solvent. Okay, so don't forget I said that the number of moles of a solute dissolved in 1 liter of a solvent. Okay, that's our concentration. Now they say, okay, the concentration of this solution here. So our concentration is C, is given by C equals to number of moles divided by the volume. Okay, but however, because I don't have the number of moles here, but instead I have the mass, so my formula changes to something else which is also equivalent to this one here. It's going to be the same as, I can say, the available mass, okay, then divided by the molar mass, and then times the volume in deciliters cubed, okay, or liters. So which mass do I have here? They said what? I have 500, ne? Yes, it is 500 grams, that is 500, divided by the molar mass, which was 342. Okay, so remember that, 342. Then multiplied by what? By the volume, which is how many? They said how many liters or deciliters cubed? They said 2. That is 2 here, times 2. So what's our answer, guys? So it's gonna be what? Let's check it out here. So I have the 500 divided by 342 times 2, which gives me what? 0.73 moles per decimeter cubed. 0.73 moles per decimeters cubed. Moles per decimeters cubed. Moles per decimeters cubed. Okay. Any questions, please ask. Don't fear. That's our answer there. Last question for today. It is question 6. It says that the first step in the extraction of zinc from zinc sulfide is combustion of zinc sulfide in oxygen. Then they say the balanced equation for the reaction is 2 zinc sulfide plus 3 oxygen gas to give us 2 zinc oxide plus 2 sulfur dioxide plus energy. They say, is the reaction above exothermic or endothermic? Give us for your answer. Now, listen carefully, guys. We have types of reactions, ne? Depending on whether they take in heat or release heat. So a reaction which takes in heat or which takes in energy is called endothermic reaction. And then a reaction which releases the heat or the energy is called what? Exothermic reaction. Now somebody can say, how do you know release and then absorb or take in? Now in chemistry, in our equations, if the energy is going to be absorbed or taken in, it must appear on the reactance side. However, if the energy is going to be released, it must appear on the product side. So check our equation now. Where do we have the energy? Talk to me. The energy appears to be on the what? On the product side, and hence the name was, so energy has been what? Given off. So it is exothermic reaction. So the answer is what? Exothermic reaction. Reason, energy has been released. Energy has been what? Released. Energy is being released. Okay. That's why it's called what? That's why it's called exothermic reaction. Okay. Next. They want what? They're saying that they say that oxygen gas consists of oxygen molecules. Define the term molecule. So what's a molecule? What's a molecule now? Talk to me. Now a molecule, it is a combination. It's a combination of two or more atoms covalently bonded together and acting as a unit. Combination of two or more atoms covalently bonded together. Bonded together and acting as a unit. Okay, so a molecule is a combination of two or more atoms covalently bonded together and act as what? As a unit. Okay, let us proceed then. Next, they said that okay, I think we are fine here. Yeah, they say what must we do next? They said that draw the Lewis dot diagram for the oxygen molecule. Draw the what? The Lewis dot diagram of the oxygen molecule. Now oxygen is in group 16 or group 6, and so because of that has got 60 valence electrons. And because this is O2, it means I'm going to be having 2 oxygen atoms, okay, which appear like this one here. So if this is my first one here, okay, my first oxygen atom, then closer should be another one here. Now the Lewis diagrams have got valence electrons in the outermost shell. So because it's group 16, it's going to be having 6. How many? 6 in the outermost shell. So let me use the excess for this oxygen here. So this one here, that is 1, that is 2, that is 3, that is 4, that is 5, okay, 5, and then what? And then 6. That is for this oxygen atom. Then for this other one here, I'm going to use the dots. Now for this oxygen atom, this is 1, 2, 3, 4, 5, and 6. Now note something here, guys, that if the electrons are shared covalently between the atoms, these ones which are shared, they are capable of moving around the whole molecule like it is. Like they move this way, they move this way like this, and like this, as long as they are shared. Okay, so this is our answer for the Lewis dot diagram. Okay, next question says what? Let's check it out. It says that during the extraction above, 7 grams of zinc sulfide reacted completely with oxygen gas. Calculate the number of moles of zinc sulfide that has reacted. Isn't it? During the reaction above, 7 grams of zinc sulfide. That's what we are noting now. We have 7 grams of zinc sulfide. completely with oxygen. Okay, they want the number of moles of what? Of zinc sulfide. So the number of moles of zinc sulfide, we know it's going to be given by what? By N. N equals to mass over molar mass. They gave us the mass, over the molar mass for zinc sulfide. Okay, so let us find out molar mass for zinc. The mass we know is given as what? It's given as 7 grams. This is 7 here. What about molar mass? Let's check it out. Now our molar mass for zinc, and then also oxygen, zinc on oxygen, is it? Yes, check it out here. So for zinc, its molar mass is what? Or is Zn here? It is 65, It is here 65. Let's go and write it down. 65 here. What about for sulfur? Now for sulfur, it is actually 32. 32 here. So if I compare to get my answer here, I get how many moles? So 7 divided by 65 plus 32. 7 divided by 65 plus 32. What do I get? I get 0.07. 0.072. 0.072. Now these are the moles of zinc sulfide present, Okay. Next question says what? They said that the mass of oxygen needed. Now to know the mass of oxygen needed, I need to know how many moles are needed. How do I know that? Now by using mole ratio, because oxygen is reacting with what? With the zinc sulfide. Let's check our equation again. Now zinc sulfide reacts with 3 moles of oxygen, So it means I'm going to use it to get my mole ratio here. That is 2 to 3. Then the moles of zinc sulfide I know. I can get the moles of oxygen, then I get the mass, Okay, so as you can see here, guys, I have it that what's my mole ratio here? 2 for zinc sulfide. Reacts with how many? With 3 for oxygen, Okay, so which moles do I have? I don't know for zinc. It is how many? 0.072. So here, this is 0.072. 0.072. Now to what? To X, which I don't know for oxygen. So what I do here, I simply cross multiply. I cross multiply. It's going to be 2 times X. That's going to be 2X. It's going to be 2x, okay, equals to what? Equals to 3 times what? 3 times 0.072. 3 times 0.072. Then later I divide by what? I divide by 2 to get my x. So therefore my x equals to what? Equals to the 3 times that one. Which one is that? Times 0.072, times what? Times 0.072 divided by what? Divided by 2 all together, Which answer do I get here? Talk to me now. What's my answer? Let's check it out. So 3 times 0.072 divided by 2, it gives us what? It gives us 0.108. So this is 0.108. 0.108. Now these are the moles of oxygen required, so I can get the mass which they want. Let me get back here now. I want the mass of oxygen required, So because I have the moles, I can get the mass, What does the formula say? The formula says that number of moles equals to mass over molar mass. Okay, so because I have the number of moles, I can get my mass. So mass equals to actually number of moles, that's N, multiplied by what? By the molar mass. Multiplied by the molar mass. So it's gonna be what? It's gonna be 0,108, 0,108 multiplied by what? Multiplied by 32, the molar mass for oxygen. So what's our answer then? Talk to me again. Answer becomes what? Times 32. So it gives me 3,46 grams. 3,46 grams. 3,46 grams. Okay. Alright, now they say volume of sulfur dioxide gets produced at STP. Now at STP they want the volume. So if I can get the moles of sulfur dioxide gas produced at STP, I can find the volume by using N equals to V divided by V molar. Let me first find out the moles here before I find out the volume. So I scroll up to get my what? My number of moles of sulfur dioxide produced. Now fortunately, the 2 moles of zinc sulfide produces 2 moles of sulfur dioxide, which means the number of moles of zinc sulfide is the same as number of moles of what? Of sulfur dioxide. So I can now get my volume. What was it for zinc sulfide? The moles were what? Let's check it again. It was 0,072. So that's what I have to use here. Now I know that the number of moles of zinc sulfide is the same as that of sulfur dioxide in it. So I have to do the calculations here. What does the formula say? That the number of moles, okay, number of moles, first of all, there are how many? 0,072. What does the formula say? Again, number of moles of sulfur dioxide at STP is the same as what? The same as V divided by V molar. Now what is this V molar? That's the volume of the gas at STP, which is 22,4. So it means that to get my volume V, I'm going to multiply the 2. I'm going to multiply the number of moles, the 0,072 multiplied by 22 what? By 22,4. 22,4. So which answer do I get here? Multiplied by what? By 22,4. So 0,072 multiplied by 22,4. It gives 1,61 decimeters cubed. 1,61 decimeters cubed. 1,61 decimeters cubed. Okay, so this is the volume of the sulfur dioxide gas produced at STP. Let us proceed. We are almost done. Don't give up, guys. Let's write the incomplete equation for the chemical reaction below, that is zinc solid plus H2SO4 to give us X plus H2. So let's say write down the name of the acid in this above equation. So our acid here is this one here. This is our acid in there. That's our acid there. So what's the name of this acid here? It is called sulfuric acid. So our name is what? Sulfuric acid. The name is sulfuric sulfuric acid, sulfuric acid, no, sulfuric acid, sulfuric acid. Okay, next they said that what? Write down the formula of product X. Now, this is zinc is going to displace the hydrogen ions, and then you proceed, then form zinc sulfate as a salt. So it's going to be zinc sulfate. I want the formula zinc sulfate like this. That is Zn. Okay. Zinc sulfate, then SO4. Zinc sulfate. So this is the zinc 2 sulfate, which is formed for X. Okay. Name the type of reaction illustrated above. Choose from acid base reaction, then precipitation reaction, or Redox reaction. That's when your answer. So in here, my answer is a redox. Answer is what? It's a redox reaction. Explain your answer. It's because the zinc is changing from 0 to positive 2 oxidation state. Check here. Now here my zinc has got here 0 oxidation state, but now becomes, this is zinc 2 sulfate, becomes positive 2 oxidation state. So because of the increase from 0 to positive 2, it means the reaction is what? It's called a redox reaction. Let me explain again. Why is it called redox? Because the zinc changes. Okay, because zinc changes from 0 to positive 2 oxidation state. Positive 2 oxidation state. Oxidation what? State. Oxidation state. Oxidation state. Okay, that's written there. Now they said that lastly that let's briefly describe a test that can be used to verify the formation of hydrogen gas during the reaction above. Now if you burn this hydrogen gas which has been produced, it burns with what? With a pop sound. Okay. Hydrogen gas burns with what? With a pop sound. Hydrogen gas burns with a pop sound. That's our answer. Burns with the pop sound. Okay. Thank you so much for watching. Once again, my name is 3.CALCULATIONS. I am a tutor and educator for mathematics and physical sciences at Rosteke College in town here, and that's from grades 10 to 12. See you again next time. Bye bye. You can reach us on 0785 222 041. Bye bye. Take care.